Good morning students, welcome to the session. Today's video I'm going to explain about activity 3 and activity 4 from the chapter 9. So what is the chapter name? Chapter 9, Electrical Conductivity of Liquids. In last video I explained about the introduction of this topic and activity 1 and activity 2 I completed. So once I'll recall the points and I will continue this present topic. Mainly the materials are classified into 3 types, but in our textbook it was given as 2. When the material, any material, if it allows the current to pass through it, then the material is known as a good conductor. And some of the materials, they do not allow the current to pass through it. So they are known as bad conductors or poor conductors. So the materials are mainly classified into good conductors and bad conductors. And one more category is they are known as semiconductors that you will learn later, higher classes. And in the 4th chapter you know that all the metals are good conductors. Now in the activity 1 we'll find out we'll take the solid substances and will they allow the current or not, we'll check it. So for that we have to make a simple circuit. Simple circuit means take a cell, LED bulb, and these are the connecting wires, and here we have to leave, these are the 2 terminals. In between these 2 terminals we have to take different materials, solid materials, and fill this gap. Then each time we have to observe the bulb glows or not. If the bulb glows, then the material whatever here we have taken, it is a good conductor. For example, if you take an iron nail and observe, when iron nail is connected between these 2 terminals, the circuit is completed and the bulb glows. And note here, when the circuit is complete, then only current flows through all the terminals, then the bulb glows. When the circuit is completed, then only bulb glows. If the here you see there is no connection from this terminal to this terminal, at this condition the circuit is open and the bulb does not glow. So here you take the different materials and each time observe, and you can find out what are the in that solid substances, what are the good conductors and what are the bad conductors. So we came to know that metals are good conductors of electricity, and even in the conductors, iron, copper and aluminum, these are having the high electrical conductivity rate. Now, what is electrical conductivity? It is the property of each and every material. This is it is the property of any given material. If that property, we can say that a material has a good electrical conductivity if it allows electric current to pass through it easily. If a material allows, it is a good conductor and it has electrical conductivity. So electrical conductivity is the property of any given material. We can check for any given material. If that material allows, then it is a good conductor. If the material does not allow, it is a bad conductor. Now, we came to know that metals are good conductors, and we tested for the solids. Now, like solids, liquids, will they allow the current to pass through them or not? Means liquids allow the current or not, or conduct electricity or not. So that we will find out from the activity 2. Already I explained, just once I am recalling this. So for this, first you have to make a tester. So tester means the electrician, he uses this tester and he put in that terminals and he check in that tester, small LED bulb is there. So if that bulb glows, then the circuit, in that circuit current is flowing. Other bulb does not glow means there is no passage of current. Like that the tester is helpful for in that circuit current flows or not. Like here, to find out the electrical conductivity of liquids, we have to prepare a tester. So how to prepare this tester? Take a cap of injection bottle which is made up of rubber. This is the cap. In this cap, you take the two metal pins made up of metals and insert in that gap, and we have to maintain some gap between the metal pins. And one of the metal pin too, we have to give the connection to the LED bulb, negative terminal. This is the negative terminal and this is the positive terminal. From the positive terminal to the battery negative, and then from positive to again to this terminal. Like that we have to give the connection. Then the circuit is ready. And here when the circuit is ready, just you observe whether the LED is glowing or not. Here the bulb does not glow. Why? Because here whatever the terminals are there, these two are having some gap. If you make them by pressing these two terminals, then immediately that LED glows. Okay, so then leave it and maintain the same gap between the metal pins. So this is our tester. And take with glasses, plastic glasses. You take different plastic glasses and take different types of solution. Distilled water, drinking water, nala water, lemon juice, oil, coconut oil, vinegar, like that different solutions, kerosene oil, milk, like different solutions you have to take in different containers or different glasses. And each time this tester, these metal pins should touch in that liquid. This metal pins should dip in that liquid and find out each time then bulb glows or not. See, when the metal pins are dipped in the solution, here again I will draw. This is the liquid. If the metal pins are dipped in the solution, then the circuit becomes completed, closed. Why? Because the electricity here, there is a gap and there is no connection between these two. But when these metal pins are dipped in the solution, the current from this terminal through the liquid, it flows through this metal pin. Means the circuit is completed and you check out whether the bulb glows or not. So sometimes like that you have to take the different solutions and each time observe, and in some solutions bulb glows, and in some conditions, in some of the solutions bulb does not glow. For example, if you take lemon juice and ordinary drinking water, nala water, bulb glows, vinegar, bulb glows, acetic acid, bulb glows. But if you take some other solutions, glucose solution, sugar solution, like that, the bulb does not glow. Why? Because some of the solutions, they are allowing the current to pass through it, but some of the solutions, they are not liquids, not the solutions. The liquids, they are not allowing the current to pass through them. So that's why they are the bad conductors. So liquids also conduct electricity. But when you compare with the metals, when you compare with these liquids with the metals or the solids, their conductivity is less. The conductivity is less. How we know? See, when you are taking the different solutions in this, the intensity of the bulb, brightness of the bulb, if you observe, sometimes the bulb glows brightly and sometimes the bulb glows dim. Because when the bulb glows bright means that liquid conducts more current, means the liquid allows more amount of current through that liquid, then the bulb glows brightly. And if you take the vinegar or acetic acid, the bulb becomes dim. Why? Because that liquids allows less amount of current to pass through it. Due to that reason, bulb glows dim. So based on that, liquids allows current, not all the liquids. Some of the liquids allows current, means they are having the electrical conductivity, but this property is comparatively less with the metals. Here you see, The intensity of the glow of the LED depends on the flow of electric current through the circuit. Although a liquid may be a conductor, it may not allow current through it as easily as a metal does. If the liquid is a good conductor, even though it allows the less amount of current when you compare with the metals, because metals are very good conductors of electricity. That's why in the testers, in the circuits, we are using LED bulb, because in the LED bulb, even if the small amount of or the weak amount of current flows in that LED bulb, that the bulb glows. Due to that reason, LED bulb nowadays, wherever you see, this LED bulb is using. Next, now coming to the present topic, we'll discuss activity 3. So what is that activity 3? When do liquids conduct electricity? When do liquids conduct electricity? See, in the activity 2, distilled water is a bad conductor. Why? Because to conduct electricity, the liquid should contain either salts, minerals, or acids, or bases, or like that. If that liquid contains acids, bases, salts, or minerals, any substances which is dissolved in that, then it conducts electricity. If you take the distilled water, it does not contain any minerals, any salts, any acids. It is pure water. So, to flow the current through that liquid, these particles are need. Due to that only electric current flows through the liquid. So that's why distilled water is a bad conductor. Can you make the distilled water into a good conductor? Actually, it is a bad conductor. So can you make this bad conductor into a good conductor? Yes, we can do. How? So once again, you take a same, this is the distilled water. Once again, I will draw the figure. Again, you take in 1 glass distilled water, and in this distilled water, just you take a small amount of salt, which we are using in our daily life. Eatable salt, take it, and just 1 spoon of salt you dissolve in the water. Then you will get the solution, and in that solution, take this tester and observe. Means these metal pins should dipped in this solution, distilled water, which are adding that means salt. Then observe that LED glows or not. Obviously LED glows. Earlier, pure distilled water, it is a bad conductor, but when you add a pinch of salt, means some amount of salt to this water, then LED glows. Why? Because that water contains salts. Next, take copper sulfate solution. Salts. You take copper sulfate solution. So this copper sulfate solution is also known as Mylituttum. What is the another name of copper sulfate? It is known as Mylituttum. So take 1 glass and take same distilled water, and in the distilled water you take a small amount of copper sulfate. It is a chemical. It is in blue color. So take that and dissolve in the water and stir it. After that, adding that copper sulfate, again you have to test with this tester. Each time while you are testing with this tester, these pins you make it dry. So each time you must wipe these metal pins with some tissue papers or the cloth and make it dry. Then only just dip into the another solution. This is the precaution. And here distilled water with copper sulfate. So then observe. So the current flows from this metal pins to the solution to another metal pin to battery, like this the bulb glows. Always in the circuit, current flows from negative terminal to the positive terminal. Current starts from the negative terminals and uh, at the positive terminal, that it ends, or negative to positive it flows. So even in the copper sulfate solution also the bulb glows. And you take next one, here you see pure distilled water. Does LED glow? No, because it is a bad conductor. When you add salt, the bulb glows and it is a good conductor. Next, distilled water with the copper sulfate. Yes, the bulb glows, then it is also a good conductor. So you, like this way, you can make the liquids into good conductors. Then the last one, distilled water with the lemon juice. So take in glass, take distilled water and add some amount of some drops of lemon juice. Again, just place this tester in that solution and observe that LED glows or not. Obviously, that LED glows, then it conducts electricity. That distilled water plus lemon juice, it conducts electricity. Then it is a good conductor of electricity. So, if a solution contains any salts, acids, bases or minerals, then only it conducts electricity. If a solution is free from all this, then it is a bad conductor of electricity. So what is the example of bad conductor of electricity? Distilled water. When you take the tap water or ordinary water, it contains some of these salts, minerals, all this. So due to that, it conducts electricity and it is good for our health. But it should be purified water only, without any impurities, dust particles and all. So water conducts electricity. Water conducts electricity. So I think no, I hope that, do you know why our means we should not touch the electrical appliances with wet hands? Because water is a good conductor. If you touch with wet hands, it contains water. So water is a good conductor of electricity. So we may get a shock. So that's why our we should warn children to means they should not touch with the wet hands. Now activity 4. What is this activity 4? Chemical effect of electric current. Means here chemical effect means the chemical energy is converted into electrical energy. For this, a small activity. So for this you need LED bulb. This is the battery cell and this is the potato. You take different vegetables, but here in the circuit I am showing potato. So take half cut potato and take 2 wires, conducting wires, and take from LED to this potato at one place, and from this LED to negative terminal, and this is the positive terminal, and this is the positive terminal. Like that you give the connection. Okay. So just to dip these conducting wires at 2 different places in the potato. Then the circuit is completed. Because from the negative to this, positive to negative, negative again positive to, like this, the circuit is completed. There is no gap. And here you have the gap, but here potato is there. Then after some time, immediately, like metals and liquids, the bulb does not glow. Just you observe few minutes. Then the LED glows or not. Obviously that LED glows. How it possible? And you can observe in this activity, you can at one end of the terminal you can see a green spot. You have to take here the copper wires for conducting electricity. So at one end you can see a green spot. So it indicates, and you can observe this green spot at the positive terminal. Means the current flows from the negative terminal to the positive terminal, and at the positive terminal you can observe a green spot. Means this spot indicates there is a chemical change in that potato. Means the chemical reaction change, means the chemical change converted into electrical chemical energy is converted into electrical energy. Due to that reason the LED glows. Instead of this you can take a carrot, a tomato, next lemon, and different vegetables you take and observe, and each time that LED glows or not, you find out. So this is about activity 4. What is that? Chemical effect of electric current. I hope you all understand. Thank you.